はい、それでは、パネルディスカッションに入りたいと思います。
We'd like to start the panel discussion. Well, we didn't take questions after each of the presentations, so if there are any questions to the three presentations, we will first address them. Yes, over there, we will bring a microphone to you. Two questions. First question to Professor Ikeda. So DS holds a lot of data, and 80% of the memory is taken by simulated data, and the data made from observation data. So based on observation data, you allocate the simulation data where you allocate across the globe. Those are very large sets of data. It's difficult to transmit them easily. So where would they fall in third pillar or fourth pillar? The number of data set may be small, but it's very big to ignore. So I want to ask about that. Another question. So Mr. Kitamoto talked about the ruins in his presentation, and he talked about the difficulty of having communication amongst various disciplines. So we have native speaker here. We have two words, discipline and domain, and in Japanese it's the same word, and maybe that could be a cause for confusion. So if Mr. Parsons can explain the difference between those two terms, that would be appreciated. Domain and discipline. So Mr. Ikeda first. So simulation and other generated data, and it's true that they're quite large, that it's difficult to transmit electronically. Sometimes they're sent by postal mail. And I think the issue is how to look at them. Basically, well, if there is something that to be discovered there, then I think it would fall into the fourth pillar. If there are papers on the institutional repository, if you're going to do mining on it, that will be the fourth pillar methodology. And so if it's generated from the third pillar, it could be handled as a fourth pillar. So Mr. Nosé talked about observational physics and experimental physics. The motivation for data sharing is different between those two. So I think the same points were made by the two speakers. So on that point, can either or both respond? Were you talking about the same things or not? And what about that case that we talked about, data that is combined from observational data? How is that handled? I didn't consider them to be the same. But based on what Mr. Nosé said, data created from simulations, I think that would be the same as experimental physics. And in terms of motivation, it must be low. I agree with that assertion because I'm not too familiar with the simulation, so this is a part of conjecture. But with supercomputers, the platform is not commoditized. It's not common. And at various laboratories, they have softwares that they inherit over generations. And so it's not shared and it's not replaceable. So whether you want to share that kind of thing, probably not. So you point out a good point. And so I think that comparison that Mr. Nosé made, I think that is valid. Mr. Nosé, would you like to respond? And until you made a point, I didn't have that viewpoint. But as you said in the question, the simulation data or volume data. So if there is data assimilation based on observation data, that kind of data. So after data assimilation, you would have a set of data. And maybe you don't do data assimilation for the upper atmosphere physics. You do. Yes, we do. So simulation or data simulation, where there is a component of the researcher's idea, I think that would become more experimental. So the altitude before the calculation, or rather the code, the researcher doesn't want to disclose because they want to get the results. So we hear about the data sharing, but the simulation code, the latest simulation code sharing, we do not hear too much about. It doesn't happen so often. So in that contrast, I think that will fall into the experimental data category. So the second question, I guess, addressed to Mark. Maybe difficult to explain, but between discipline and domain, what's the difference? Is there a difference?
I think domain is bigger. To be honest, it's a distinction that I've only recently come across myself. But my interpretation is domain is very large. So earth science or something like might be a domain, whereas oceanography would be a discipline. So a discipline is within a domain. Domain is very big and broad.
Hi.
Thank you. Any other questions? Over there, please. Question to Mr. Ikeda. Last slide, one more thing slide. You talked about the two ways of making repositories, database type and the Google search type. I think you didn't have enough time to explain those two things. Can you elaborate? So I think many people here belong to the library community. So you first have the taxonomy first. So how to categorize the world is already determined beforehand. But that people are not necessarily satisfied with that. In mathematics, at least at the Kyushu University, we have a unique categorization. So that the categorization is not necessarily universal. Now, depending on the field, I think nature of data is quite different. And to have a metadata or put it in a database or to determine the schema of the data, I think is not so meaningful for metadata. So acquisition date or file size, it will be limited to those very general kinds of information, not be so useful for searching. That's the point I wanted to make. If it's just for the purpose of searching, then adding various indices to the data, so connected with words, that would be sufficient for the information retrieval. But the point I should make is that if you're really going to use that data, you have to know about that discipline. I think that's what Mr. Kitamoto said as well. So even if you're able to search like Google, then you have to really go into the depths of that discipline, so maybe not so useful. So you're talking about searching about the metadata. Well, when you search for data, if you try to abstract with metadata, then data is quite different by each discipline. So you would have very general metadata, and it's not really useful for searching, is what I wanted to say. Understood. Any other questions or comments? Are we good? So amongst the four panelists here, listening to each other's presentations, do you want to ask questions to each other? So within the group, maybe we will raise some questions if you want to ask for clarifications. Go ahead. So in Japanese, I have a question to Mark. Page 34. you talked about the data fabric. So you have raw data, and so you register the raw data. So let's think about a sensor network. Data is continuously being generated. So how do you set the unit for registration? That could be very subjective. How you set the unit for the data to be registered. What do you think about that?
And I don't think I have a straightforward answer. I think it's going to be very contextual as to what is the unit of relevance and what granule or what piece of the data deserves its own identifier. I can tell you in my former data center, we were trying to move towards, so most of our data was file-based. We had some in databases, but most of it was file-based. And so we were moving towards having identifiers on every file. And but then having something like, not a DOI, but something like a UUID or an ARC for every file. And then aggregating that at some level, maybe by time or by space or instrument or whatever and then giving a larger identifier to that and putting the metadata on that collection. But I think it's sort of what constitutes a collection and what constitutes the atoms of a collection. It gets back to your point, which I thought was very good, is we don't have that sort of generic model of what is data. And honestly, I think that could be one of those endless philosophical discussions. Data is in its application. What I might think of as data, you don't. What is text for you might be data for me. So data is made by its use, in a sense, is defined by its use, in a sense.
Hi.
Okay, hope that satisfies the question. So let's have a discussion amongst us under some common themes. Well, one point before that, I'd like to make an additional comment. Earlier, we talked about the experimental physics. Well, in the case of experimental physics, it's experiment per se. So experimental data per se is independent and you don't have too much motivation to share them. And in the observational physics, the observation itself is something that people will be motivated to share. Now, this time we didn't have a person in bioscience as the speaker, but in the case of bioscience, the results, the product is something to be shared, like genetic structure discovery or interaction. So that discovery itself is data, and that is something to be shared. So that's another case that can be envisioned. So you do various experiments, you do calculations, and then you make discoveries, and that discovery is subject to sharing. So that's another different type of data, and there's another set of motivations there. And if you don't make that open, actually you won't get recognized for that outcome. So there is that kind of culture. So from here, I start my question. In that case, research or data, in conducting research or data, who to give credit to? The researcher, the people involved? What are the various positions on this? What is the current situation, or what is the more ideal situation? I'd like to hear the opinions of the panelists here.
If it's a paper, well, this is a difficult point, but we have the same or similar question for paper. So who is the author? Who should it be combined with? So in various fields, we have the same question. So we have to expand it. So if we just talk about data, there can be no answer. But so inclusive of that, who's involved and whose name should be put in making data public. So who? So from your own vantage point, we'd like to have comments. So which order? Well, anyone? Okay, Mark.
It's a very big question. Let me give several perspectives. So I talked a little bit about data citation, and it came up a few times in some of the other talks as well. And I've been involved with the concept of data citation since the 90s. And I can tell you that my original motivation with data citation was to provide an incentive to share, to provide credit to the people who put intellectual effort into making a good data set, which may be a researcher, maybe a field technician, maybe a computer programmer, maybe all of the above. I think over time that motivation for data citation has actually really changed a lot, and that there's more of an interest in citation being a precise reference to the actual data used for the sake of validating an argument or enabling reproducibility. And so it then opens up the question, did data citation as an incentive for sharing work? And to date, I don't think we're seeing really any good solid evidence that it is an incentive to share. And so I think we need to actually maybe sort of take our step back with this whole concept of credit. Is what are we trying to incentivize? What are we trying to reward? What are we trying, and similarly, who needs to be accountable for different things? And so in the research realm, particularly if you're a professor or you're working to be a professor, citation in a recognized high-impact journal is the currency of the realm. That is the important thing to have. If you are a field technician and your specialty is in experimental design protocols, instrument design, you are not measured by your publication record. You're measured by, how successful your designs were, how robust your instruments were. And so you may not care about citation, and you may want to be credited in a different way for a different sort of thing. So I think there is a parallel to literature, and we're seeing a lot of work in literature where increasingly journals ask the authors to actually state the different roles of the different authors. And there's projects out there. One of them I know of is called Project Credit, that is trying to actually break down all the various different roles in the whole research enterprise and then try and maybe put badges of credit on those different roles. But I think it's still maybe getting a little ahead of ourselves. What are we trying to credit for whom and in what context? And so this notion of authorship of a data set, I think, is important for some researchers and in some contexts, and for others it's completely irrelevant. And that the way that they want credit is, that their boss hears that they did a good job, or that they, get listed in their professional societies, who's who or something like that. So I think we have to think, before we start thinking about who to credit for what, we have to think about what are we trying to incentivize. So I answered the question with a question.
Thank you. So probably so it's so that step back. So we asked why we want credit. Right. Okay.
Well, Mark's intervention was very interesting. Now, the purpose of data citation has been changing. That's what I thought was interesting. Now, citation. The credit is the purpose. Well, I think that's ideal. Well, to me, I think that's ideal. But then why has it gone to reproducibility? Because from the perspective of the current journals, what is useful? If you employ that concept, then I think things go in that direction. So from that perspective, citation should be looked at from the reproducibility viewpoint. And so if that is the idea, then we tend to go in the direction of reproducibility. So the journal controls this word, and so the dynamics tells you that that should be the direction. So credit for data, well, I think that's a big issue. As what I mentioned in the presentation, in the previous presentation, what I made a proposal or a suggestion. Now, in various academic societies, we should create a prize for the shoulders of the giant. That means, in English, it's called shoulders of giant. So research is to create the shoulders of the giant. That's what, from Newton, that's what Newton is said to have said. It's an important keyword. So the value of research is whether you're creating the shoulders of the research. That should be the measure. And so journal is just one measure, and data infrastructure creation, and how close is that to the shoulder of the giant. And that should be the yardstick to do measurement. Then citation is just one measure, but people in the community know who made that. That often happens. For example, if that's his data, it's trustworthy. Well, it's not explicit, but that's the situation. So, it's just a credit, it's just a word. So maybe we should create a yardstick that way. Right. Mark made a presentation in the morning, and dynamic citation, dynamic citation working group was mentioned a few times. Yesterday, including Mark, amongst the discussants, we had a reception, and some people talked about dynamic citation. And in fact, as far as I'm concerned, RADA, not September, but March in San Diego, dynamic data citation was the word that I heard at that time for the first time. Now, information, Vienna Institute of Technology, Lauber, is the leader in this concept. In the data set, some portion should be made citable. Not the whole, but some portion should be citable. In other words, that person should get credit. It's possible for that to happen. Yesterday, Nosé-san, I was talking to Mr. Nosé. Maybe there's no need to do that. Maybe some people say that. What we said was, Mr. Nosé's word data center data. Well, I used that the other day. Word data center, unless you write that, the person whose data was used, he or she doesn't know who used that. But when it comes to details, during this period, this person, and this person, A, B, C, can give credit. Or perhaps a few years ago, maybe a late person who's already dead can already receive credit. That may be possible from a relatively technical viewpoint. That's what I think. I don't know whether that should be the case, but technically that's possible. Data, whom? Citation. If we expand the topic to citation, credit, whose name should be noted? So it's a smaller question that I was trying to discuss with you. As I said before, data center, I am working at a data center. Research is my work, but also at a data center, I manage data. And I distribute data. That's part of my work also. So as I said in my presentation, in our field, data sharing is accepted. It's a part of accepted culture, and it's done as a matter of fact. Usually, if you use data from a data center, your name is put in the acknowledgement. So who used the data? Well, that was not really visible to date. So this may not be the right word, but well, working free of charge, well, for nothing. Well, the person who got the data, or the person who managed the data, the person who provided the data, these people should be given credit. And as Mark said, those people who do observation, well, maybe they don't think about those things. But the person who got the data, well, the credit should be given from that person. So in a way of like metrics, the evaluation should be able to happen, ideally.
I just wanted to follow up because I think I understand your question better. Who should get credit? And I think many people should get credit, and they should be credited in different ways. So if you're thinking about sort of the author of the data set in the sense of a data citation, I would say it's the person or people who put the intellectual effort into creating that data set. Maybe they designed the algorithm, or they designed the experiment protocol. They may not have actually physically collected the data, but they put the intellectual work into it. Now, the person that actually physically collected the data probably also deserves credit, but in a different sort of way. And then the data center that maybe compiled that data, put metadata around it, and made it available, they also deserve credit, but in a different way, maybe more like an editor or a publisher as opposed to an author. So I think we need to think about those different roles. And I really liked Kitamoto-san's notion of where are the giant's shoulders? And so in the current method, you get more credit for a minor paper than you do for a really significant data set. And I think it's important to recognize that data are used well beyond scholarly communication. So most of us come from Earth and space sciences, and those data are used for all sorts of things, for agricultural prediction, for disaster response, for telecommunication planning. And that is as important, or perhaps more important, than some of the scientific use, and that is never going to be captured in a citation. So maybe we need to be looking at reuse and that broader reuse of data deserves more credit, and that there's different roles that deserve that credit.
Thank you very much. Now, according to what we've heard, in the case of observation, traditionally, credit was not written, but now going forward, data will be shared and used more broadly. Then credit should be done more explicitly, which would be better. That's the direction, perhaps? May I? Well, personally, because, well, I say this out of my personal interest. Well, I have become interested in data because the provider of data or the collector of data, credit should be given to them, and also, what should I say, acknowledgement. There should be a metrics that can quantify that. So that's why DOI, data citation, should be promoted. That's why I got interested in this, and that's why I'm participating in this. As Mark said, the observer, well, they deserve a lot. Well, the side that decides the citation at the data center, who should be, well, cited, well, they can decide that. So in this respect, data citation culture should be promoted. Then I think appropriately credit can be reflected.
Thank you. Which also means perhaps it's possible to do that at the present time by various methods being provided. In the past, it might have been less flexible, but there is no issue as to how many credits you give to how many people, as well as you can also track it through by current technology. And because of that current technology enabling all of that to the future, for sure, that is a good direction for data sharing to be further pursued. We have been sticking to too much perhaps of our on this topic, so we may need to address other issues which are similar. One of them is data generation, where researchers, as in the past, as well as research institutes as their mission, or perhaps it was a self-motivated effort. Having said so, the level of motivation may vary, but if you really want to share data, there are cumbersome processes or work that's involved. Mark has mentioned saving data is hard and sharing data is even harder in his presentation this morning. If so, of course, we should, it would be better to have more support from outside the research community, or who would be providing that research ideally, is the question. Or in other words, data sharing. Who is going to help us in data sharing? Once you produce your data or generate the data sets, the action of sharing is accompanied by a certain cost. And who should bear that cost or share that cost is what I'm trying to ask. Would like to hear your comments. Nosé-san, as I've understood, your center has that mission originally. So that mission, as with your center, remains the same. Yes, at least. To a certain extent, researchers or domain scientists, to an extent, have to be engaged, because unless you understand the data, it would be difficult to provide the data to others. So scientists need to be engaged, to a certain extent at least, to the future. Solar terrestrial physics in our discipline, or even beyond that discipline, in earth sciences, if we're going to share data more broadly, data curation, or whether I should use the word curation is proper here, is another question, but we do need that capability. So we just can't pass through data. So researchers, and if it's beyond that research discipline, we need help and support from those who are like-minded. So that is to mean that we need a separate team of data curations or data curators. I'm not sure if I have correctly understood data curation, but Mark has mentioned earlier that if you create a data, you can enhance the value of data, is what I understood from this morning. In our area of solar terrestrial physics, a single data set will not be valuable, but once we connect and link them to 2 or 3 data sets, it does broaden the scope and adds more meaning and significance to data itself. So, for instance, if you can locate one database to another database and combine data extensively, those experts that could, if it could be institutionalized, we can add more meaning into the data or add more value. So, for instance, what you're saying is that curators and museums in each discipline or area of art or science, they appreciate the value of each piece of data. And of course, they can collect data, for instance, or plan a certain exhibit by bringing a collection together. So that kind of capability is needed, I think, if you're going to give an analogy. Any other comments?
Well, I think I largely agree with Nosé-san. We can't escape that we need the subject knowledge of the expert who collected the data. And I think it's reasonable that researchers have a role to play in making their data reusable. And I think it's a professional skill and it's a professional responsibility, and it's a skill that should be taught. You can't get through graduate school without taking a methods class. I would argue you shouldn't be able to get through graduate school without taking a data class. That said, I don't think it is the researcher's primary responsibility. We need that subject level knowledge, and so you can't escape that, so they have a role. But data should be viewed, research data in large part should be viewed as a public good. And so there's a public responsibility to ensure that that data is useful and reusable. So you need to pay for professionals who are responsible for making that data as useful as possible. Those curators, those data managers, those data scientists. And they have to work closely with those subject level experts to interpret and reinterpret and provide different contexts to make that data broadly usable. So it's a collaborative responsibility. But I think it's very important that researchers recognize that they have a role, but we shouldn't put it all on the researcher. It's not fair for them to take on this whole burden. And indeed, they should actually see value from sharing their data. And in fields like solar terrestrial physics, I think they do, because they make it available through the data center. It has greater value in context with the other data. In other fields, maybe they don't see that value. But I think that's something that professional data managers have to try and emphasize, is they have to make sharing valuable for the person who's sharing the data, not just for the person who's reusing the data.
はい、どうぞ。じゃあどっちか。じゃあはい。
はい、キュレーターが重要っていうのは、それ。
We talked about curators. So of course, I'm completely agreeing to Mark's comments of curators are important, but curators are not enough. Mark has mentioned that infrastructure is important in his presentation. And if it's an infrastructure, we need architects, civil engineers, naturally. Therefore, it's like a building construction project. And if it's a construction project, we need extensive skills and talent, which would be just similar to architects and owners of the projects talking to each other in the process of building something. And if we scale it out as to that scale, we need more scaling up here. And therefore, experts of informatics would naturally be involved. Having said so, architects or civil engineers equivalents in the construction field will have to build together a system, is what I think about, as is the picture that I have in my mind, having listened to what has been said. Institutional repositories is also a part of my research. In sharing papers, for instance, in my discipline or in each domain, databases have been shared in the form of archives, for example, as well as PubMeds. At the same time, we also have coexisting institutional repositories. But domain repositories, there are huge repositories. Some of them exist, but the smaller repositories are having a very hard time. Just recently, we had 3 years back a disciplinary repository workshop. For instance, philosophy. They are following PubMeds and archives to come up with a business model of a huge repository of first advancers. But I don't think this is a methodology of researchers originally. Those who are well advanced might be off well because they started and established their business model. For instance, permanent storage. I think institutional repositories have a role here, but curation on top of that, I think it might be better to have hypothetical repositories. There wasn't a presentation that I gave in mathematics of how we created that upper layer repository, and I think the same would apply to data. For instance, if research institutes or universities, as an obligation, register data. In fact, Kyushu University and Kyoto University, as basic policy, their research notes and lab notes, they have set a policy that it should be stored 10 years from publication. And if this spreads, universities would have to develop infrastructure for storage, which does not involve as much of curation, but more lower data handling procedures or knowledge or any skills if necessary. And areas other than that, for instance, each discipline or domain could provide more knowledge, as well as astronomy, for instance, is a very strongly user-generated area, for instance. So if we had that second layer on top of the basic infrastructure for those specific domains or disciplines, it may work effectively. The issue that has been just proposed is a very delicate issue. And could I ask Mark here? In Japan last year, we had falsified research in Japan that was published, and that aroused huge social concerns. Gracious storage and has been discussed in reality as a resulting consequence. And open data has been mixed up most often in discussions. Therefore, as Ikeda sensei has mentioned earlier, the students or the labs at universities, if the notes are kept in glacier storages, we need systems and costs for storage and systems. The theme that we're addressing today, to open data to advance sciences, have been all mixed up, especially university administrators. Research ethics, to a greater degree, is in their mind currently at present. And in my personal opinion, these should be separate sets of discussions that are currently mixed up in Japan. Ethics or research ethics in the Western world Do you have that established and separated from this issue? And also, personal information is also an issue, though we haven't addressed that at this forum, as well as in mostly in medical data. And opening up databases usually works negatively in stopping opening up databases from that barrier of personal information protection. And how is this all handled in the Western world of opening up databases?
I don't think the Western world has solved this problem either. I'm not sure. So I like your point that we should separate concerns. I'm a big fan of that. And so much, you're right. So much of this gets intertangled, and these issues that we've been talking about, credit. The flip side to credit is accountability, and so that's this notion of having falsified data or irreproducible results. That's not a problem solely in Japan. There's been a number of studies that have shown that the data behind research is either false or unavailable or unverifiable, and I think that's what's pushing us more towards citation being a method of accountability than a method of credit. And then the broader ethical discussion, I think it's important to separate that out, but also I think it's important that it does run into it bumps into a lot of different things. I think maybe this is something we should be also thinking more about, how we train our researchers in the ethics of data sharing. And at the first level, I think it's not ethical to deny access to your data, but when you make your data accessible, it must be accessible in an ethical way, not impugning privacy rights or endangering protected species or damaging relationships with indigenous peoples. There's a number of ethical boundaries, but they should be ethical boundaries, not proprietary boundaries on data sharing. I don't think I'm answering your question, because I don't think anybody has really solved this, and that there is a tendency to sort of make it all interwoven, and somehow we need to start thinking about how we can separate those concerns. And I think on the very specific issue of data citation, I think it's very important to think about separating concerns. The credit issue is different from the reproducibility issue, is different from the provenance issue. And citation may help with all of those, but it is not a solution necessarily, a one-stop solution for everything. And I think we need to be very cautious of anybody that proposes a panacea-type solution, a solution that addresses many different problems. So I'm not sure I helped, but...
Okay, please. Conversely, I think that there should be more entanglement. Well, maybe not better. I think it's acceptable to have all those tangled together to talk about the privacy issue. There's, of course, data that cannot be made open, but to open what can be made open, that can be done by the power of information. Now, to promote the open science, if we just talk about that, and we had the same philosophy for open data, that would not be viable as a business model. So institutional repository, they increased in number because they left it up to the institution. And if that institution thinks that it's important to attract students or not, I mean, they have that choice. So numerical database, we used to call them, and based on my experience working with those databases, so as Mr. Kitamoto said, Professor Emeritus, before they die, they want to open that data, make it openly available. That's the most undesirable kind of data, because the database, you have to maintain it continuously, or else it will die. And to ask someone else to take care of already dead database. That's very arrogant, and just giving it to a data curator, will it elongate the life of that database? I don't think so. We've been talking about successful databases or successful data sets. They are all built by organizations. There is a data center or something, and so that it is not based on a personal effort, individual's effort. It has to be maintained by the community. So there's that community-based effort, and that leads to the open data discussion. So in the field of small science, if they are collecting data on an individual basis, they are left behind from this kind of development. And I think that's the most important point. So we have joint use facilities in this country, but maintaining database for the community, there are very few who have that kind of orientation to maintain that kind of database. And so for your own research community to maintain a database and make it publicly accessible, people have not thought that to be an important task, but that's where we should start. So for individual researchers within a bad environment, to ask them to make an extra effort, I think has a high probability of failing. So there could be differences amongst disciplines, and I think that has to be accepted. And Ikeda sensei, I think, has already experienced that kind of a hardship leading to what he's doing now. So that's exactly the intent of my question. So instead of leaving it to the researchers, there should be help provided by someone else. And who to build that kind of a system is an issue that needs to be addressed. So this issue of data sharing, it should not be just left completely up to the researchers. That is clear. So who should be involved? What should be the system to be put in place? I think we can agree that that is an issue. Of course, there is no one answer. Maybe curation, or to understand that there is such a work or role as a curator. That may be the first step, and that can be solved by computer science. So maybe make best use of computer science, and also for each community and the discipline, conduct and set up explicit activities. That may be some of the points that you have raised. They are separate, but they probably have to be conducted together in order to make things work. I'm starting to run out of time. Now, very briefly, well, near the end, there was a discussion about the personal data. And when we talk about open data, open license is mentioned. So any kind of reuse is accepted, but that's not necessarily always the case for open data. But if you have any thoughts about licensing, can you talk about it? So when I say licensing, it's about taking the data to whom you allow it to be used, a set of rules defining that. Do you not need it at all? Should it be CC0, or should there be some limits? I think there are different views on this. So if we may get a short comment. Mark, please.
Data that are collected with public money should be viewed as a public good. And that gets to your question. I think that therefore there's a public or a research-wide responsibility to maintain those data. It's not just the responsibility of the sole researcher. So as a public good, also it should be made publicly usable and accessible within ethical constraints. So I like the CC0 public domain waiver or their associated public domain mark, which as much as possible puts the data into the public domain. As opposed to something like a Creative Commons license, which license by definition puts some constraints on things. But the thing that I like about CC0 is that it's putting it in the public domain, but it also gives you the opportunity to reference community norms. Because I think the way we are going to address this is not through law, but through scientific norms of behavior. There's no law that says you have to cite original source. You just won't get published if you don't, because that's the way science works. So we need to have a similar attitude and foster that sort of norms-based attitude that it's good ethical practice to share data and make it as open as possible into the public domain as much as possible, in my opinion.
My view is already in the presentation slide. From open to closed, there is a spectrum. It's a continuum. And therefore, there are various choices available. And the so-called open data, that's one extreme, I think. And there are various variations, and we should have variations. But if there are infinite number of variations, it will not be machine readable. So it has to be sorted out. But I talked about the DS project. And in the DS project, there are many different licenses, and we haven't been able to organize or sort through them, and that's something that we like to do, but each different, so it's not so easy. And so CC0, that kind of open data, that's one extreme, I think. So there should be a lot of variations between CC0 and completely closed for business. Now, research data and license, I really haven't given too much thought about that topic. Once it's made open, I think I thought it would be something that can be used freely. But I thought access control is more important. And so on the infrastructure side, create a system to make it easy to use the information. I think that's necessary. Focusing just on natural science data, ultimately it should be open and shared. I think that's a given. And several researchers have told me that researchers, they do research with tax money. Of course, there could be research that could be done by that individual's pocket money, and they can keep that closed if they like. But basically, you collect data with some support, and of course there's a lot of effort, so there should be some rights given to publish the paper first, but the data should be made open eventually. But how to collect data, only the person who made the instrument would know, so there should be credit to them, and you should contact that person and then make the data openly available. I think that's the ideal that we should aim for. So I think people have different positions, but I think it's enough for today that we understand there are different positions. I'm a little over time, but with that, we'd like to close the panel discussion session. Thank you very much for your participation.